solving max and min of binomial quadratic. So we'll be doing max and mins here. It's called a binomial. Bi, like a bicycle, means two, and nomial means numbers. Okay, so in this polynomial, which means many numbers, there are two. 1, 2. Okay, so that makes it a little different because we're used to seeing, and this can be considered in two different forms. Okay, this could be close to factored, or it's not factored, sorry, standard form where we have ax squared plus bx plus c. Okay, because we have 4x squared, which could be related to this, and 9, which could be our c, so that could look like standard. Okay, and I'm going to show you how to a trick to finding solving a binomial quadratic in standard form very quickly. And then there's actually a really fast way to do this if you can visualize. Okay, this is actually also very close to ax minus h squared plus k. Remember vertex, and vertex makes it very easy to find the actual value with our h and k. And I'm going to relate it to vertex at the end, show you the trick. So first we'll do it as standard, because most people would see this as standard form. Well, the good thing about it being a binomial, okay, when we're looking for a standard form here, is what we're going to do is we're going to find our x-intercepts very quickly. Okay, so our x-intercept, well, our x-intercepts are when y equals what?
0.
Yeah, so this is when y equals 0. So in other words, f at x will now become 0. So 0 equals 4x squared minus 9. Okay, well, I want to get x squared by itself. So when I move 9 to the other side, what am I going to get?
9
is equal to 4x squared. I need to get x squared by itself, so how do I move 4?
So you can split it.
We divide both of them by 4 because this is 4 times x squared. We're trying to get x by itself. That's our goal right now, okay? So the whole time what we're trying to aim at is this x, we want to get it all by itself. Okay, so when we do that with the 4s create a 1 or cancel out, and we're left with 9 over 4 equals x squared. Right? The 4s disappeared. They divide into each other. Think of it like this. 4 divided by 4 is 1. And what would 1 times x squared be?
1.
Well, think of it like this. What would 1 times 5 be?
5.
So what would 1 times x squared be? What would 1 times a million be?
A million?
Yeah. So we're catching a pattern here?
X squared?
Yeah, that's right. 1 times x squared is just going to be x squared. So these are kind of side calculations here, okay? So since 1 times these 4s created a 1, so they were 1 times x squared, well, I don't need to really include the 1. I just have x squared now. Again, I got to get x by itself. How do I move a power of 2 over? What's the opposite of that? No? Okay, the power of 2. So any number to the power of 2. So we'll call it a power of 2. The opposite of this is the root of 2. The square root, also known as, okay? So I can square root both sides. Well, if I square root and square x, they, again, cancel each other out. That's exactly what we were doing with the 4th and the 9. We technically added 9 to both sides of this equation, and we canceled out our 9s. Then we canceled out our 4s, and then we canceled out our square. That's the process of balancing an equation or isolating a variable. We're always just trying to get rid of everything else. So we're now left with x by itself, okay? Because we canceled it out. But on the other side, oh geez, that's not what I was looking for. On the other side, I actually got to figure out what the square root of 4 over 9 is. Well, what's the square root of 9?
3.
Yeah. And what's the square root of 4? 2. There you go. So your square root of 9 over 4 is 3 over 2. But here's the trick. Square root of 9 is not just positive 3. It's also, yeah, and the other vice versa. So our answer is technically plus or minus 3 over 2. Okay. So our x is plus or minus 3 over 2. Or in other words, remember we talked about splitting. X is either equal to positive 3 over 2 and or x is equal to negative 3 over 2. Okay? So with that being said, we got our x and our y axis. One of the x intercepts is at positive 3 over 2 and the other one's at negative 3 over 2. Okay? Now here's the trick. In between these the axis of symmetry, do you know where it's going to be? When we add those two numbers together, what we're going to get? 3 over 2 plus negative 3 over 2.
0.
That's right. So we're getting 0 over 2.
0.
0. So the axis of symmetry falls right on the y-axis. Okay? So then we can go back up to our original equation, being f at x is equal to 4x squared minus 9. Well, when the x value, this is what we discovered for the vertex. Okay? First of all, does it open up or down? Is the 4 positive or negative?
Up.
Yep. And we know the vertex is right here on the x-axis. So we know the x value is 0. We're finding the y value. So we take this 0 and plug it in for x. So f at 0 is 4 times 0 squared minus 9. Well, what's 0 squared?
0.
Times 4?
0.
0 minus 9?
9.
Not 9.
Negative 9.
That's right. So our vertex is at 0 and negative 9. Okay? So that's the long way. Here's a really quick way. I'm going to look at this again, because I know like it looks like it's in standard form. We had 4x squared minus 9. Okay? Because it's a binomial, think of it like this. Vertex form. Ax minus h squared plus k. Okay? Well, our h, in this case, think of our h like being the value of 0. Okay? So our h is 0 in here, and x plus 0, well, it just gives us 4x squared minus 0. So what is my k value in this question?
9.
Negative 9, right? So I know x and y. So for my vertex, my y value is going to be negative 9, which we technically found before. And because there's no number in that bracket, yeah, we assume it's 0. So now we already have the vertex without doing any of that work. And does it open up or down? Is 4 positive or negative?
Oh, it opens up.
Yeah, that's right. It opens up just like we said. Right? Opens up, so is it a max or a min?
Minimum.
Minimum at the value of 0 and negative 9. Okay? So that's kind of like a shortcut. I'm trying to view it as if it was in vertex form. That's like a visual thing.